if I was teaching this lesson in class, I would 100% be nerding out about it because limits are the foundation for calculus, and I'm very excited about them. So I'm not going to apologize for nerding out on this video as well. You're just going to have to get used to it. Um, if you have a graphing calculator, that would be handy to pull out for this activity, but if not, that's fine. You can just kind of pay attention to what we're doing with it. We're going to be using it to explore some things, or this function specifically. You could also try using Desmos when it comes to graphing, or your phone calculator, although it might be a little tricky with these very specific numbers and this rational function. So like I said, if you don't have one, it's not the end of the world right now, and just kind of follow along. So today what we're going to do is we're going to discover what a limit is, when it exists, and then when it doesn't exist. And to do that, the first thing we have to consider is this rational function and its domain. So to find the domain of rational functions, the domain is automatically all real numbers except any number that would make my denominator 0. And so to figure out what number would do that, you can just set your denominator equal to 0. So x plus 1 equals 0. And then that results in the x value of -1. So this would make my denominator 0, which would make my whole function undefined. So the domain of all of the numbers that work for this equation are all the set of all x values, except for x is not allowed to be -1. So every other x value I could plug in here and it would work, just not -1. Okay. And now we're going to look at the graph of f of x, and we're going to probably do a sketch of it, but I want to talk specifically about what happens on that graph. So if you have your graphing calculator, you can kind of follow along. I'm going to go to my y equals screen, and then I am going to plug in my equation, making sure to put the bottom and top separately in parentheses. Oops, not quite there yet. -4, there we go, divided by x plus 1. And then I can hit zoom, and then I want the standard window, so zoom 6. All right, so automatically I know that maybe my graphing calculator isn't showing me anything because this just looks like a regular linear function, and we know that this is not a regular linear function. And so I'm going to go ahead and write that down. So it looks linear. But what would actually be happening if we were able to zoom in on this graph really far? What we would see end up happening is we know that there isn't a point at x equals -1. So there isn't a point right here. We just are zoomed out too far to see what actually happens here. And so if we were able to zoom in all the way, here's what you would actually see. So it looks linear. But if I zoomed in at -1, what would end up happening is I have this graph, it does this, and then there would be a small hole because there wouldn't be a point there, and it just keeps going. Looks linear, but there's a hole. And now what we're going to do is we're going to explore what happens when we get increasingly close to this discontinuity. That's a pre-calc word, discontinuity on our graph. And so to do that, we're going to examine some x values that are increasingly closer and closer to -1. So we're going to go ahead and fill out this table. So the first set of numbers I'm going to consider, -3, -2, -1.5, and so on, are values that are said to be approaching -1 from the left. And that's because they are values that are less than -1, but getting closer and closer to -1. So like -3 is over here, then -2, and then -1.5, and then we're just getting closer and closer to -1 from the left-hand side. And so I'm going to go ahead and we're going to plug these values into our calculator. And you can, if you wanted to, you could actually go through and you could just plug in -3 squared minus 3 times -3 and so on and so forth. But that gets a little tedious. So here's a really quick calculator trick for you. If you want to try a bunch of different values in your function, make sure it's in your y equals screen. And then we're going to use our table. So we're going to hit second, and then table set is right here. And what you can do from here is you can go to your independent variable, those are your x values, and you can tell your calculator, hey, I don't want you to create those for me. I want to ask you for specific x values. So once that's selected, go ahead and you can go to your table now. And now we can tell our calculator which x values that we want to look at. So we can go ahead and we can plug in -3 like we want to do right here. So if I plug in -3, oh, that function would give me a -7 out instead. I can plug in a -2. I could plug in a -1.5. And so this way you don't have to keep going through and entering this over and over and over in your calculator. If you wanted to define just a set of data using that function, you can definitely use this. So my numbers that I'm plugging in are getting really, really close to -1, but never actually hitting -1. And so we can go ahead and we can fill out what we got in our table. -7, -6, -5.5, -5.25. Whoa, got a little crazy with my 5 there. -5.1 and -5.001. Okay, so as our x values approach -1, the y values, or f of x, or height, I'm approaching as I near the x value of -1 is called my left-hand limit. So as my x values approach -1, what does it look like that my y values or my function is approaching? So what would be the left-hand limit of f of x? Well, it looks like it would be -5, and so let's write it out with proper notation. So I would write out the limit of f of x as x approaches -1 from the left-hand side. That's what that little negative up in the kind of like exponent spot is. This means that I'm approaching -1 from values that are less than -1 but really close to it. And I would say that the answer to that, it looks like my y values are approaching -5. So that you have found your first limit. The limit of this function as x approaches -1 from the left-hand side is -5. Now we're going to do the same thing, but we're going to do it from what we call the right-hand side. So values that are greater than, but increasingly close to -1. If I look back up at my sketch that's up here, I'm going to be trying like 1, and then 0, and then -0.5. So I'm picking values that are going to be closer and closer to 1, or -1, excuse me, but from the right-hand side. And so we're going to find the right-hand limit. And to do that, we can do the same thing using our graphing calculator. We're already even in the table mode over here. So I'm just going to go ahead and fill out this table using our calculator. So I'm going to plug in 1, 0, -0.5, -0.75, -0.9, and I'm getting very, very close to -1, but not actually hitting it ever, because that would make my function undefined. All right, so let's go ahead and fill out our data that we got from there. This would be -3, -4, -4.5, -4.75, and oh, I missed one, didn't I? Oh, where'd my 0.9 go? -0.9. Oh, there we go. -4.9, and then this one was -4.999. Okay. All right, so now if we talk about these values, so the what does it look like my function is approaching as my x approaches -1 from the right-hand side? Well, it looks like that I'm still approaching -5. I'm going to have negative values that are getting closer and closer to -5. So now I'm going to rewrite that using proper notation. So the limit of f of x as x approaches -1 from the right-hand side, that's what the little plus means up in the corner, is also -5. Wonderful. And so now I'm going to kind of do a visual of what happened there. We can go back, and if we look at our graph, we can kind of see what we're going to draw. So it looks like at -1, I know that this is where my hole is going to be. And then it looks like I'll have another point right here. And so my graph kind of goes this way and it kind of goes this way. And now if I was going to draw my limits on my graph, I'll use a different color for this. Oops. If I was going to draw my limits on my graph, my left-hand limit means as I approach this -1 from the left-hand side, it looks like I'm getting closer and closer to -5. And then from the right-hand side, same thing. As I'm approaching -1 from the right-hand side, my graph gets closer and closer to that y value of -5. It never actually hits it, but it gets closer and closer to it. When our left and right hand limits are both approach -1, both exist and are equal, then the general limit exists and is written like this. So our previous limits had little pluses and minuses up here to represent the left-hand side and the right-hand side. This one's just your general limit. And because our left-hand and right-hand limits were the same, we would say, yes, our general limit exists. And if so, what was it? To write it in proper notation, the limit of f of x as x approaches -1 is -5. Wonderful. In this next part, you guys can go ahead and just for yourself write a few sentences or one sentence describing what a limit is and how it is found. Whatever you need to write down for it to make sense for you that's completely up to you. So go ahead and take a minute to do that. If you need to pause, now is a great time.